All right, hi everybody. I was originally going to do the conclusion, and I realized right when I was actually about to start making all the levels that we had a little problem that I'd forgotten to fix since basically one of the earlier levels, I would guess. Well, no, actually, no. Since we moved to reading a file based on the number of characters, so over in here, right? We basically started relying on the fact that we're dealing with rectangle levels, right? So this width is always the same and this height is always the same. But what about cases where that isn't true? In the previous one, we basically stored a vector of strings and then we could find the longest one and then we were totally fine. The longest one being like the longest width. And since we already had a vector, we had a guaranteed height, so it didn't really matter. And then we could fill in after the fact. But we don't actually have that. So when we get in a level like this, for example, what we have is a problem, right? Because the width of this line isn't equal to this line, but the way we've where'd it go? Did I lose it? Sorry. Sokoban C++. The way we've set it up is we're just assuming everything is the right number of columns. And the reason why we're doing that is basically what we're doing is we're setting this p.x and p.y and we're using that to set the bits. And so like the number of rows is getting messed up because we're storing this Sokoban index. Yeah. So we're calling Sokoban index, which is using, where is it? State.columns. And so it's just getting messed up. So the question is, how do we fix this? And originally what I had planned to do in my like head when I was gonna make this video, but I just realized there's a better way live, was I was gonna use something like this where basically we clear and then we reload the file. So we do like a double pass through. And then what we can do is we can find the width and the height in our first pass through the file, our level file. And then the second pass through, we can actually load everything into our bitboard or bit set now. But I'm realizing we don't actually need to do that. And the reason why we don't need to do that is because we have everything set to mins and maximums just to guarantee certain behavior. So if I'm not mistaken, in our constants, we have this level max width and level max height. We do. So what we can actually do is this is the number of columns. So we can do level max. Before we actually, let me just put this in here. I'm not going to make it. Instead, I'm just going to show you the problem when we actually are in level 8. So this is our problem level where things aren't in the right thing. So once we get to here, rather than going all the way to here, our bit set is basically going to say that the next row starts here. So everything is going to start to get off, right? Because we're going to start to set from here and yeah. But if we go into here, right, this looks fine because we're in a rectangle. This looks fine because we're in a rectangle, but this looks insanely bad. And you can see this is right, but then what you can tell is right here where this is, it's actually right here. That's because it's based off of like this or something else in our, like basically our state.columns and state.rows is wrong. So that is the problem. And we can actually get one fun behavior like this all of a sudden. Oh no, we can't actually go this way, so that's fun. But this is a totally unsolvable level regardless. Like, oops. We can solve, no, it's just totally unsolvable. But it's fixable, right? If I'm not mistaken. So we change this level max width. We make it. We'll see, Sokoban, and let's see if it just works just out of the gate, because that'd be kind of cool. Yeah, it just works out of the gate. So this was originally going to be like a video where I basically just try to show you how we could read through the file twice and we could create this kind of advanced thing, but I realized we don't need to do it. We have a much simpler approach, which is just to say this is our level max width. It's always going to be the same. We're clearing all the bits at the end anyways. We're not doing like a smart, like kind of like in restart, right? We're clearing all the bits, not just like the targeted set of bits like I think we were doing at one point. So it doesn't actually really matter. So we're just totally good. So the one other thing I wanted to do was for this video, I guess it's going to be one of our shorter ones, and then we'll get into the conclusion um, as the final video in the series. So the other thing I wanted to do was I changed it to a ring buffer, right, in main.cpp. No, not it's a game. Why am I using my mouse? Like yeah. Okay. So we have this commands.clear. I think we should call that regardless, just as like good practice. And we can, yeah, we'll just call it regardless. Okay. What I wanted to do very temporarily was there was a Jonathan Blow video kind of recently actually, where basically what he talked about was this pattern that he liked, where basically what you can do is like, if you have void complicated function, right? And you're trying to optimize it, but so basically what you can do is rather than make changes directly to that complicated function where you could accidentally change the behavior, what you can do, for example, is write a new complicated function, make this the old one, so all your calls go into this void complicated function new, right? And then so every single call to the complicated function is still going to go to here. But then what you can do is you can say, like, just for convenience, let's just say these both return ints, right? You can say like int a. Well, we can actually just do assert, right? Complicated function old is equal to complicated function new. And then once you're reasonably confident, maybe you add unit tests, maybe you do some integration tests, maybe you just eyeball it like we tend to do. You can just remove this assert once you're happy and get rid of the old code. But until that point, you can just start asserting things, and you can kind of get this like really easy and convenient way to compare the two functions. Now, in our case, we don't have as easy of a job because really what we're doing is we're comparing two data structures. So I'm going to just do it like this, where we're comparing our pooled linked list commands old to commands, right? And then if we go into game C++, what we can do is we can do commands. Yeah, so what we'll do is in here, keep that commands.push, oops, old.pushback, and then commands. How do I even get this? I don't have a, yeah, I don't really like that. So let me fix that. So we have our pop back, and there was actually one other thing I wanted to do. This needs to be fixed at some point. Oh no, we fixed this. Nice. That's what I wanted to check. Okay, so pushback. We can also do we make two versions? But we'll see. Back. Let me see the pop back, yeah. No accept. And then what we can do, right, is we have this and then we can just return ring buffer this, there, and then I can also, just for my sanity, just rename this into data, because I just feel like that's a little bit better. And then we're getting an error because this is saying there's a back like index, and then we're making a function call back. So we could name it like get back, which I think is reasonable. I definitely prefer not doing it like that. So we also have pop front, which okay, we're still not even gonna bother with that. Let's just do that, and then we'll also have t. Can we do like a const t reference? And then get back const no accept, and then this is the exact same thing. One thing I'm starting to think about is for this data structure is we're just like constantly like using this kind of line over and over again. So we could make like a function which is like back index, front index, which would maybe make our life a little bit better. that I'm thinking about, but we'll just leave this for now. Okay. So push back. Okay, so now we're in here. So this, get back. What I almost want to do, because we already had it working like this, so I think maybe what we actually make it is this. And then what we can do in here, right? Oops. From there, then commands dot pushback, and then commands. Oops. Where'd I go? Oh, I went all the way into the ring buffer. Commands old. Is there like a old dot back data? What is it? Is it just this? I don't think it is. Pool node, and then it's like dot data, but I don't love that. So maybe this pooled linked list really should have like a way for you to not have to pop, and it can just return the back. Let's see. Remove front, remove back, pop front, pop back. Yeah, so that's fine in a sense, but let's add a T get back, right? And we'll add our no accept, and this can return back data, and then we can also do the const version, no accept, and then I think we do const there, return back. I don't love all this typing. Like, is this really necessary? I haven't actually like done a Google to double check, because it feels a little silly that we can't just like, whatever, it doesn't matter. So we're in here, and then get back. While I'm here, let's do the other version just because we're thinking. And while we're thinking, we ought to act. So we'll do like get front, right? And right now we have a problem, but I'll come back to this in a second. Front, and then we need to assert front does not equal null pointer, right? This, and then we need to assert that it's back. That is not equal to a null pointer. Are we asserting elsewhere in this function? Yeah, we are. Cool. We're doing those exact asserts. Okay, so in here, right, this is basically what we're doing right now. We're basically just doing everything twice. And then what we can do is assert commands old dot get back equals commands. I don't think we can actually do what we're looking for right now. The reason being, right, is we have like these two back commands, and we have a command, but we don't actually have that. So let's operator overload. Not a huge fan of it. Maybe what we do instead is we do bool equals const command other. We want to reference. This is a const no accept, right? And then what we can do is other dot move block equals this dot move blocked. Oops. Move block and end in our point. I think, yeah, we'll do that. So this is player direction dot equals other dot player direction. It's a little long for my taste, so we'll do this in 2 lines. And then we can go into point header file, right? And we have this like, so I guess we'll do it like this just to follow. I kind of like a little bit more object oriented, to be frank. Just a little bit. x equals other.x and y equals other.y. So we'll do it like that. We'll also, I don't love the whole, I don't love operator overloading, to be totally frank. That one I think just makes things a little bit weirder, like in terms of like hidden behavior. So, but equals, this is fine. And then player direction. Okay, so the problem is, let me go back to point header file. This needs to be a const no accept. So now that's totally fine. Player direction equals other.player direction. We have this, we have that. And now instead of doing equals equals, right, we just do equals. And now everything's explicit in terms of like exactly what's happening. We're doing a constant reference, and that works. Okay. And we still have this like kind of like old way of doing it. So we're going to do this, this. We'll comment out this. And then we need to change -1, 0, right? We'll do this one now. Yeah, and I kind of, okay. If I could go, I can go back. It's not like, okay. Let me just do, okay. So I go here, right? I do this, and then I make this a 0, I make this a 1, and then I just comment this out. When we're satisfied, everything's working as we want, then what we can do is we can just remove these lines again and everything will be fine. So this is R1, R0, R for being replaced. We have that, so that's right. I'm just checking -1, -1, 1, 1. So that looks good to me. And is there anything to do in here? So the next one, commands.clear, and then we also need to do commands old.clear. This is one of those where if we like wrapped it, it would be a little bit cleaner, but since we're just doing this for a quick test, it's not turning out to be a quick test, but for a test, that is okay. So what we'll do is we'll do like star cmd is equal to command old is equal to commands old dot pop back, command new is equal to commands dot pop back. And there's an error. Oh, they're saying this needs to be like a const, I guess. Cool. So we do that. We don't want to do this anymore, right? We just want to do command new, doesn't really matter. And then we need to assert cmd old equals cmd new. Simple enough. Now in this one, right, we just need to do commands old equals pop. Do I have, oh, dot pop front. And then we don't actually care about storing them, if you understand what I mean here. So instead of doing that, instead of like storing the two and using them like we were using in here, we can just do this. But there's a problem, which is I did this instead of this. So now that's fine. And let's see where else we use commands. Commands.clear, commands old.clear. Yeah, I definitely made this more complicated than like the Jonathan Blow example, but that's okay. So we have this, commands, 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 just running through the examples just so we can see. Okay, so right here, we want to make sure the commands.count is equal to commands old dot capacity or dot size. So this is one of those things that we should actually look into potentially fixing. Because right here you can see like we basically like we're not gonna make it so like we have like a generic container for different like data structures to go between, or at least not for now. That is something we could do where like we have like our base like data structure type, and then like you can just like implement like get size, get pop back, pop front, whatever. But at that point we might as well just like use the C++ standard, right? So what I want to do in here is instead of doing it like this where we are using size, I really just want to use, I think I'm just going to use count instead, just to be a little bit more consistent across our data structures. So count is equal to count. That looks fine to me. Now we're comparing that. And then we're not going to get to this in our test case is, so I'm just going to leave that. Well, we can do it. Commands old. I don't think we even have like, do we? Okay, it's fine. And then we're back at the top. So a lot more than I would have liked, but we're using everything, and now we can go into the ring buffer and fix whatever mistake we have here. Type const command does not provide a subscript operator. And so we have a data, right. I named it to, I named this data and then I changed the name of the ring buffer. Unfortunately, are we logging in here? I don't think so. Okay, that can go away. So we can fix this real quick. Data, push back, push front. I think I'm starting to lose my voice just a little bit. Const t data. Okay, so let's maybe name this something else. If it can't be data, we can make it, is an array like reserved? Ring buffer, I guess, was fine. Just list, I guess, let's call it. And then this needs to be fixed to list. And then I think we're hunky-dory, if I'm using that word correctly. Yep, that is correct. Sokoban, play, boom, boom. So now like we're doing all those asserts, which is kind of cool. Or at least I think we are. Let's double check that we actually are. So on just like in a random one, assert false. We'll call pushback at some point. Make it. And Sokoban it. Good. So you can see like that is calling. I was concerned for just a second there that we weren't doing it because of these like optimizations, but we haven't actually disabled asserts through this yet. So I can't see. There it is. Sokoban, play. So you can see this is working. And yeah, everything is working in terms of this. I'm going to leave this on, like all of these checks, if you will, while I'm making the levels. And then in the final video, which I'll hopefully record later today, I'll have 30 or so levels that we can play through. And I'll keep these on. And then the final commit will basically just be getting rid of these tests. And then if anybody wants to go look at the project, add to it, change it, etc. Right? It's just, I have a link in the description down below. It sounds weird saying that out loud. And I believe, yeah, so the code is under the MIT license, essentially meaning do whatever you want for it, just don't sue me, is my understanding of it. And here's the, oh, I could have just clicked that, that's cool. There's the README. I also added our speed tests into here so you can see like with pre-initialization and without pre-initialization. One thing I don't like about the choice I did in the video before was I'm just outputting the total time, not the time per iteration, right? But whatever. We could have also increased these. We could have also made these like configurable, so like hashtag define or constants, whatever. But yeah, that's the video. So the next one finally is going to be the conclusion. I think that takes us to 30 parts. I think this is part 30, and then the conclusion will be part 31, if I'm remembering correctly. But yeah, we've been working on the project for a while, and it's exciting to get to the end of it. So yeah, I'll see you guys in the next one. And yeah, thanks. Bye.